Today's lesson is 1.4 experimental design. Our goal today is to be able to explain the importance of control, randomization, and replication within an experiment. So we'll start with an example of an experiment with folic acid and birth defects. For several years, evidence had been mounting that folic acid reduces major birth defects. Dr. A.E. Seisel and I. Dudas of the National Institute of Hygiene in Budapest directed a study that provided the strongest evidence to date. Their results were published in the paper Prevention of the First Occurrence of Neural Tube Defects of Preconceptional Vitamin Supplementation. And you can find that study in the New England Journal of Medicine. For the study, the doctors enrolled 4,753 women prior to conception and divided them randomly into two groups. One group took daily vitamins containing 0.8 of a milligram of folic acid, whereas the other group received only trace elements, minute amounts of copper, manganese, zinc, and vitamin C. A drastic reduction in the rate of major birth defects occurred among the women who took folic acid. 13 per 1,000 as compared to 23 per 1,000 for those women who did not take folic acid. In contrast to the observational study considered in example 1.5, this is a designed experiment and does help establish causation. The researchers did not simply observe two groups of women, but instead randomly assigned to one group to take daily doses of folic acid and the other group to take only trace elements. So in this scenario, we're going to point out the control, the randomization, the replication. So the control. The doctors compared the rate of major birth defects for the women who took folic acid to that for the women who took only trace elements. So you can see then the control would be the trace elements. Randomization. The women were divided randomly into two groups to avoid unintentional selection bias. So we talked about that randomization in our earlier lesson that helps to avoid bias. Replication. A large number of women were recruited for the study to make it likely that the two groups created by randomization would be similar, and also to increase the chances of detecting any effect due to the folic acid. In the language of experimental design, each woman in the folic acid study is an experimental unit. Or we also refer to that as a subject. So to reiterate, we have the definitions. Principles of experimental design. The following principles of experimental design enable a researcher to conclude that differences in the results of an experiment not reasonably attributable to chance are likely caused by the treatments. So we have the definition of control. Two or more treatments should be compared. Randomization. The experimental units should be randomly divided into groups to avoid unintentional selection bias in constituting the groups. And we have replication. A sufficient number of experimental units should be used to ensure that randomization creates groups that resemble each other closely and to increase the chances of detecting any difference among the treatments. And then we have these terms that we just referenced, experimental units or subjects. In a design experiment, the individuals or items on which the experiment is performed are called experimental units. When the experimental units are humans, the term subject is often used in place of experimental unit. Now we have an additional term here, the confounding variable, which is any extra variable influencing the experiment and is not accounted for within the experiment. So this is page 1 for our notes on experimental design. We talked about these terms: control, randomization, replication, as well as experimental unit versus subject. And finally, we talked about confounding variable. If we wanted to look at this situation, we could talk about confounding variables that are not accounted for. Now, this is a very well-designed experiment, and yet we have these individual women who have individual situations going on where they may come from different health backgrounds to begin with, and they may have heredity in place that has demonstrated that birth defects are common within their family genetics. And so the initial health of the women could be a confounding variable.